Okay, let's dive into this. Welcome to This Explainer. Today we're unpacking a really profound shift in technology, one that is honestly probably changing the way you work right at this very moment. We're talking about the fundamental challenge of how we as humans communicate our intent to machines. For decades, we've had to basically bend our minds backwards to speak the rigid language of computers. But now, well, computers are being asked to speak ours. We are rapidly moving away from writing strict step-by-step code and shifting toward just writing natural language prompts. So what does this all mean? Today, we're going to explore exactly what that shift looks like, how it completely changes problem solving, and the genuinely surprising legal consequences of handing over control to an AI. Here's a quick roadmap for the structured journey we are about to take. We'll start with the evolution of intent, then explain the declarative programming paradigm, look at prompts as declarative code, explore the modality gap, and finally wrap up with ceding control to machines. It's a fascinating ride from computer science history all the way to United States copyright law. Starting with Section 1, the evolution of intent, bridging the human-machine divide. Let's move to and see how this builds. Human thought is incredibly associative and intuitive, right? We usually start with just a gut feeling or a broad, fuzzy idea. But a computer's physical architecture, it requires absolutely exact deterministic instructions. This creates a historical three-step cognitive bridge from abstract human thought down to physical execution. Step 1 is intention. That's the informal space of a task living purely in human thought. Step 2 is formalization, where we take that abstract idea and write a program expressed in a formal language. And then Step 3 is implementation, where that code is executed by the physical machine. For most of computing history, the ultimate bottleneck has been right there at Step 2, forcing humans to formalize their messy thoughts into strict, totally unforgiving syntaxes. Moving on to Section 2, explaining declarative programming, the what versus the how. Over time, programmers realized that forcing humans to micromanage every tiny step of a machine's execution was, well, just incredibly inefficient. To really grasp this paradigm shift, just look at the imperative paradigm. In languages like C or Java, you write out the instructions step by step. You explicitly dictate exactly how to do something. Managing memories, setting up loops, tracking state changes, it's exhausting. But with the declarative paradigm, using languages like Prolog or SQL, you completely flip the script. You simply describe the logic, the rules, and the constraints. You are just telling the computer what you want. You don't write a loop to search a massive database. You just state the specific data you need, and the system figures out the rest of the puzzle. So the crucial point is that declarative programming aligns beautifully with how human thought actually works. Take a logic programming language like Prolog, for instance. Instead of writing a complex procedure to find a family member, you just declare a few facts. You say Alice is the parent of Bob, and Bob is the parent of Claire. Then you declare a rule about what makes a grandparent. You don't micromanage the search through the data. You just declare the facts, ask the question, and let the underlying inference engine do all the heavy lifting. It's a massive, game-changing leap toward how our human brains naturally solve problems. System designers love using the coffee machine analogy for this, and honestly, it hits the nail on the head because engineers love hiding messy mechanics. Think about it. As a user, you provide the coffee beans and the water, and boom, you get coffee. The abstraction boundary completely hides everything else. You don't need to know the thermodynamics of the heating element or the pressure metrics. You define the what, and the machine entirely hides the messy, mechanical how. Declarative programming does exactly this for software. Section 3, prompts as declarative code. Natural language as the ultimate abstraction. And this brilliantly illustrates how we've essentially taken the declarative paradigm to its absolute extreme in the era of large language models. As one developer discussion beautifully points out, words are squishy. Natural language is inherently filled with implied context, nuance, and, let's face it, a lot of ambiguity. When a human has an intent today, the final instruction carrying that intent is no longer a perfectly structured SQL query or a rigid Prolog rule. It's just conversational English. The coding implementation has been entirely abstracted away from the user. When we prompt an AI today, we are basically acting like a product owner giving instructions to a massive development team. Our input is just a broad idea, like asking for a cartoon spaceship. Our function is merely setting the thematic constraints. The process is completely iterative. We tweak and tune the prompt over and over based on the output we get back. But the actual execution, the drafting of the complex code or the rendering of the individual pixels, that whole shebang is abstracted entirely to the neural network. We've absolutely mastered the what, but we are completely 100% blind to the how. Which brings us to Section 4, the modality gap, the cost of ambiguity. Now, what's really interesting about this slide is that it perfectly maps out the ultimate trade-off of this entire paradigm shift. We gained massive cognitive flexibility, right? But we traded away mathematical certainty to get it. Look at a traditional declarative system like SQL. Your input is exact syntax, it runs through a deterministic solver, meaning the result is absolutely predictable and auditable every single time. But with generative AI, your input is natural language. The execution engine is a probabilistic black box. The output is non-deterministic and highly variable. You can literally give an LLM the exact same prompt twice and get two entirely different results. Developers are actually calling this the prompt and pray dilemma. And if you've ever used an LLM for coding or image generation, you know exactly what that feels like. Every single time computer science moved to a higher level of abstraction in the past, we always kept a rigid syntax that allowed for predictable debugging. But natural language is squishy and ambiguous. If the AI is just making probabilistic guesses about what your words mean, well, we're no longer doing deterministic engineering at all. We are basically negotiating with a probabilistic black box. This makes it incredibly difficult to audit enterprise workloads for security, reliability, or exact performance. Finally, Section 5, ceding control to machines, the legal and philosophical fallout. So what actually happens in the real world when we give up the how? Well, we collide head-on with the law. Just imagine a prompt engineer. They spend hours and hours refining the absolute perfect natural language instructions for an AI to generate a stunning image. They feel like the creator. But legally, because they gave up the actual execution to a machine, the United States Copyright Office views them merely as a commissioning party. They are the person who ordered the painting, not the actual painter. Under foundational copyright principles, your highly detailed prompt is really just an unprotectable idea. It genuinely doesn't matter how long or hyperspecific it is, it still does not dictate the exact visual or textual arrangement on the page. Because the AI model possesses inherent unpredictability, what data scientists call conditional entropy, the machine is the one independently executing the traditional elements of authorship. You can't claim copyright over the sweat of the brow that you didn't exert. The human creator is completely recast as a mere conceptual initiator. We started computing history with humans painstakingly adapting our thoughts to rigid machine code. Now, through the ultimate declarative interface of natural language, the machines are adapting to us. We literally just ask for what we want. But when we entirely abstract away the execution, when we no longer control the how, who is the real author of the outcome? Thanks for joining me on this explainer, and keep questioning the systems you use every single day. See you next time.